Okay, guys, so let's answer the question. So we're doing example one. I have the data set, the X values, which is the age of the child in L1. And I have the number of irrelevant responses that are appropriate to the child age in L2. The first question was to create a scatter plot. And I'm gonna walk you through the steps again to do the scatter plot, guys. You press second and Y just to make sure that stat plot is turned on. And as you can see, it is turned on in my case. How do I know it's turned on? I see the on selected. I see the first one, type, which is a scatter plot. The first one, you see the dots there, and make sure it's L1 and L2. Let's say you have L1 and L4 here. So then you make sure you put the X values in L1 and the Y values in L4 if you want it to work. So we quit. And to display the scatter plot, zoom and stat, and number 9, zoom stat. And here it is. Oh, we still have the line of best fit, which is, that should not be there if you don't want it to be there. And I'll show you again. There you go. All right, so that's the first part. Do you notice that there seems to be a relationship? And how can you tell if there is a relationship? You can tell if you think that the points are very close to some line, which is we call the line of regression or the line of best fit. And you can see the points seem to be very close, you know, to some line that looks like this, for example, guys. Here you go, you see, they're all covered, you know, just with this line. So there is a line of best fit. The second question, find the correlation coefficient R and comment on the relationship between X and Y. Okay, to find R, guys, first of all, you have to make sure that diagnostic is on. So how we do this, I showed you last time, and the information are in the handout. The handout is very rich, it has lots of stuff there. Second, and 0, number 0, and then you scroll down until you hit diagnostic. You don't have to do that every time you do this chapter. Only if you reset your calculator, you have to do it. Okay, here you go. Diagnostic on, just press enter twice. And now I can show you how to find R. You go to stat, calc, number 4, L1, okay, my data is in L1, L2. You guys, if you have anything there in frequency list, you have to remove it. If you have an older calculator, it's just gonna show you, I'll show you what's gonna show you. It's gonna show you this, and then you just press enter. So you can see R is negative 0.97, which is very close to negative 1. And comment on the relationship, what did I say here? R is negative 0.97. Since R is very close to negative 1, there is a strong negative linear relationship between X and Y. And X, guys, is the age of the child. And Y is the number of irrelevant responses. It would be nice if you write this in words and you don't write X and Y. Okay, C, find the equation of the line of best fit, the regression line. Use your calculator and the steps explained above to derive the equation. Well, I've already explained the steps and I just mentioned them. So you already have it. We just did it. So let me just do it again one more time. Stat, calc, linear regression, and watch, guys. Calculate. So y equals mx plus b. A is the slope and b is the y-intercept. I told you last time, guys, instead of writing y, you put a y with the hat to say that this was derived from the sample, and we write it like this. Y hat equals, okay, A, I'm gonna round it to 3 decimal places and B to 3 decimal places. If you round them, you get negative 0.963x plus 17.30. Here you go. Let me just move this down. All right. Now we're gonna do part D, which is the most important part here. I like your attention. This is the part that we haven't done yet. And I'll explain it to you. Okay. Is everything clear so far, guys? Before I do this part, and once I do this part, we're almost done with this chapter. Any questions so far? Okay, let me explain part D, guys. And this is all, part C again. Part C, you just do this. Someone is asking me about the part C. You go to Stat, Calc, number 4. There you go. And linear regression AX plus B. Just press enter. Okay. If you have an older calculator, it's not gonna show the screen, guys. So just press enter again. But for me, I just have to scroll down until I hit calculate. So when you play this video again, you can see what we did. And look, I got y equals AX plus B. A is negative 0.96. If you do it to 3 decimal places, will be negative 0.963x. So all you need to write that, you just write the equation again, y equals ax plus b. You replace a with negative 0.96, and you replace b by 17.30, and that's it. And instead of putting y, as I told you, just put a y with the hat on top of it, just to say that this was generated using the data given in the problem. Okay? Now, and we decided that we think that there is a strong negative correlation between, or relationship between, the age of a child and the irrelevant response based on the sample. So let me tell you about part D, guys. Please just bear with me for a few minutes until I explain this, and we'll go from there. It says at the 1% significance level, test for negative correlation. Okay, R was generated from the sample that was given to us in the problem, and R was very close to -1, which shows that probably there is a strong negative relationship, linear relationship between X and Y. But the question is, guys, is if among, the sample that we have, we decided that there is a relationship, the question is there a general, a global linear relationship always between the age of the child and the number of irrelevant responses, even if we go outside of this sample, if we go to the entire population? So what we have R was derived from the sample, but the question is, can we generalize and say that there is a linear relationship between X and Y for the entire population? So this is the question now. We already know about the sample, but if we go outside of the sample, can we conclude that there is, in general, you can go out and say to people that there is a strong negative correlation between the age of any child and the number of irrelevant responses? In order to answer this question, guys, we need to test a number called rho. Let me just mark this number right here. This rho is called the correlation coefficient, but not of the sample. It's called the population correlation coefficient. This is the correlation coefficient of the population. This number, guys, you cannot find. It's impossible, because in order to find this number, you need to have the age of every single child in the entire population and the score on the test or the number of irrelevant responses of every single child. So that's not possible. But we can test it. Just like we tested the mean of the population, just like you tested the proportion, we can test this one. So this is called the population correlation coefficient. And R, guys, is called the sample correlation coefficient. So I wanted to distinguish between the two. This one, we don't know. R is the sample correlation coefficient. We know, we already did it. It's on the calculator. Now what we're gonna do, guys, we're gonna use the value of R to test rho. So it will be using R to test the population correlation coefficient. And I'm gonna walk you through steps and how to set up the null and the alternative hypotheses and perform the hypothesis test in order to test the population correlation coefficient. So there is no technology can find, just rho for you. Simply, we cannot do it because it is the population correlation coefficient, but we can test it and decide whether the correlation is significant for the entire population or it's not significant. So let me explain to you how to set up the null and the alternative hypotheses, and then we go from there. I will do the test using the calculator first of all, and then I'll show you how to do it, by other means. Okay, guys? Okay. Let me show you how to set up the first step. So I left this blank on purpose because I need it. Okay, so it's rho. We're testing rho. Here's how you test rho. I'm going to show you the 3 scenarios and explain each one for you. What was the question? The question was test for negative correlation, as you can see, guys. Okay. This is rho. This is rho. I'm going to put the other one. There are 3 scenarios. You always select one of them. Write it like this. It's just like a bent L. Watch. Okay. Look, it's very simple. Against 0. And I'll tell you why we do it against 0. So it could be this, or it could be that, or it could be equal and not equal. So you guys, you have to select one of those. And let me explain why 0. Okay. We said about R, if you remember, we said when R is very close to 1, we have strong positive correlation. When R is close to -1, we have a strong negative correlation. But we said when R is close to 0, the correlation is weak. That means no correlation. And here it works the same thing against 0. When we say rho is less than 0, that it is away from 0, but from the negative side. So that means here we have correlation. And over here, guys, you say we're including 0. When you include in 0, that means correlation is not strong. So we say it's not significant. So in the null hypothesis, correlation is not significant. And in the alternative hypothesis, correlation is significant. Look here for number 2. When I say rho is greater than 0, I'm saying that my number is away from 0 from the positive side. So for the alternative hypothesis, the correlation will be significant. Now less than or equal 0. Once I include 0, guys, that means the correlation is weak. It's not significant, because when R is close to 0, as far as samples, the correlation is not significant, the relationship. Same thing here. When I say rho is different from 0, that means I'm saying I'm away from 0, but could be from the right or from the left. But when I say rho equals 0, I'm saying that the correlation is weak because I'm very close to 0. So we're not going to write a claim here where the claim is. We write this, guys. We always make one of 2 statements. Now, let me show you the question here. It says, at the 1% level of significance, test for negative correlation. So can you guys guess what is it gonna be? Is it gonna be number 1, number 2, or number 3? Can someone tell me? Yes, I agree, number 1. As simple as that. Now, how do you tell me if it is a number 2? If he asks you to test for positive correlation. So always when he says positive correlation, it will be number 2. When he says negative correlation, it will be number 1. Any guess, guys, what would be the question to select number 3? Let's see. No correlate. He will say test for correlation. No equal. He won't say the equal sign. He will just say test for correlation. We don't use the numbers -1 and 1 because these are for the sample. So here, positive, watch guys. Positive correlation, I'm gonna write them. And you're gonna notice guys, in the book, he uses the same language, negative correlation. Here could be positive or negative because it's different from 0, so there will be correlation. Test for correlation. And sometimes, guys, when you do your homework in the book, he will ask you test that rho is less than 0. So he tells you that this is what he wants you to test. So you know you select this one. Or he asks you to test that rho is greater than 0. And this is a pronounced rho. I don't know how to write this one. It's this. It's a Latin letter, guys. It's rho. So when you write it down, don't write the L. It just bent, you know, just the bottom of it a little bit. So it is rho. This is called the population correlation coefficient. Okay. So in our case, guys, it's gonna be, I'm gonna write this down. Rho greater than or equal to 0, rho less than 0. And look what you write. Here you write correlation is significant, which is the claim here, but we don't write the word claim anymore. We just write this or that. Same language. That does not change from one problem to another. Is not significant. So in the null hypothesis, the correlation is not significant. In the alternative hypothesis, the correlation is always significant. And your claim, I can tell you guys, it's always gonna be in HA, which is correlation is significant. Now let me show you how to perform the test. This is a t-test, linear regression t-test. It's very easy test, you will see it. We're gonna do it using technology first of all, and then we'll proceed. So this is the first step, guys. I got it complete. Let me show you how to do the second step. So we'll go to the calculator. Okay. We're gonna clear. We're gonna go to stat. We're gonna go to tests. And you guys, if you want, you can scroll up because the test is right at the bottom. And can you guys see the test? What's the letter? Let's see what you said here. Not F test. We say it's a linear regression. Which one would that be? It's a bit, oh, you said letter F. Oh, okay, I'm sorry. You're right. It's a linear regression t-test. Exactly, guys. For chapter 9, this is the test that you will be using. All right, so let's go to it. Oops, sorry. All right, I'm there. Enter. Okay, watch. Very easy test. You already have your X values in L1, Y values in L2. Frequency, don't ever change this one, guys. I never change it, don't change it. Now choose the sign from the alternative hypothesis, just like you do in the other tests. What do I select? The first one, the second one, or the third? This is the alternative hypothesis, guys. Okay. One of you are saying that select the second one, and I do agree. It is the second one, so I'm gonna scroll down. And here you go. That's not selected, it's blinking, guys. You have to do it like that now. All right, and hit calculate. And actually, you're gonna like the output that you're gonna see. Watch. All right. You see T, the test statistics, negative 10.74. I'm gonna write it down, although I already put the explanation on the next page. I will write it down. And the p-value is 6.65 e minus. So let me write down this, guys, and I'll put it back. So step number 2, T is negative 10.743. P-value, I'll write it as is. We'll interpret it together. 6.56 e negative 6. But look, it gives you the degrees of freedom. It gives you the equation of the line again, which is, but it's, what do you notice a difference between the equation of a line that we did and here? The one that we did, it's called ax plus b. Here it's a plus bx. So the one who wrote this program decided to swap a and b, which is okay. You will still get the same equation. But I would like you to scroll down, guys, and see what else you get here. R squared, and not only R squared, you know what we're gonna get after R squared. We're gonna get the value what of R. So actually you get everything that we did before through this screen right here. R is negative 0.97. You got R squared, which we got S, which we talk about it later. We get the equation of the line. And the most important thing for us that we get the test statistic and the p-value. Okay, let's discuss the test statistic and the p-value. And he said, do it at the 1% level of significance. So, okay, this is T. P-value. We're gonna interpret this. E minus 6 means you have to move this 6 digits. So this is gonna be, guys, 0.000006566. So you guys agree with me, this is almost 0.000. All right, which is less than what? Alpha. So the decision is what? To reject the null hypothesis. And if we reject the null hypothesis, you just write this. There are 2 conclusions in this test, not 4. It's very easy. If you reject HO and your claim is in HA, the correlation is significant. So you say there is enough evidence at the 1% level of significance to conclude that correlation means relationship, guys, linear relationship, is significant between the age of the child and the number of irrelevant responses on a test. On a standardized test. Okay, as I told you, the possible choices, guys. I don't want you to think this is the solution of the question. I'm trying to explain the lesson here. You could have this, which is in our case here, test for negative correlation, positive correlation, and correlation here. We got the test statistic, which was negative 10.74, as you notice. This is the formula to find the test statistic. I'm gonna explain to you in a second. And the p-value, guys, turned out to be 0.00006, as you notice. It was less than alpha. We reject the null hypothesis right here. And then there is enough evidence at the 1% significance level to conclude that there is negative significant correlation between X and Y. I prefer, guys, to write X as the age of the child and Y instead of Y, write the number of irrelevant responses. Now, calculator computed the test statistic T. This is the formula for the test statistic. You might come across some problems when you do your homework online asking you to find T. Using this formula, I'm going to show you how T works, and we'll do this together. So T is R, remember guys, it was negative 0.97 over, watch, square root 1 minus R squared. You can get it off the calculator, or you can just square negative 0.97 divided by N is the sample size. How many children were there? If you count them, guys, if you count how many in the table, there were 9. So it's 9 minus 2, not minus 1, minus 2. The degrees of freedom, when you do a linear regression t-test, it's N minus 2, so it's 9 minus 2. How would you do this on the calculator? Let me show you how you can do that. Okay. You always can do the linear regression t-test, so you don't have to worry about this. So there's a work around it. But let me just show you how I would have done this. Okay. Put negative 0.97 divided by. Now I have to open square root. Second and square root. 1 minus. You know the negative 0.97 is squared. So the negative, when you square, they will become positive. So I'm just going to do 0.97 squared. Oops, I made a mistake here. I should have done parentheses first because we're dividing by 9 minus 2. So I'm going to just clear this and do parentheses. 1 minus 0.97 squared, close parentheses, divide, and 9 minus 2, guys, don't enter 9 minus 2 on the calculator, otherwise you need parentheses here. So just do the math. 9 minus 2 is 7. And now, with this, get out and press enter. And you get negative 10.56 or 5.56 or 5.57, which is fine, although you're going to tell me your calculator did not produce negative 10.5566, you got negative 10.7. Can anyone explain the discrepancy between the two answers? If you do it by hand, that's fine. This answer will be accepted. And if you do it by the calculator, what you got off the calculator will be accepted. Does anyone know why there is a slight difference between the two answers? We didn't do anything wrong here. Let me know, guys, if you have any comment on this. The reason is very simple, guys. You should know. Now, when we do critical value, I'll come to this later. It's a different way of approaching that, but I'm just going to continue doing the problems and finish this exercise. You see lots of writing here. I'm trying to explain to you as if you were not listening to me right now, guys. So actually the answer to part E should be 1 line, but I'm trying to explain what we did here. So in E, find the predicted number of irrelevant answers Y when the age of the child is 8 years. We already have an equation, guys, which is Y hat equals negative 0.963x plus 17.3, which we got it in the previous part, correct? Okay. He's telling me, find the predicted number of irrelevant answers y when the age of the child is 8. And I think we touched on that last time. You guys told me, some of you told me that we will replace x with 8, and I agree. But you only can do that if correlation is significant. If you end up in the question before approving that there is a significant correlation between x and y, then this equation will be valid. If the correlation is not significant, we cannot use the equation. Since we say that there is enough evidence to conclude that correlation is significant, go ahead and replace x with 8. You want to do it, guys, and tell me what the answer is? If you do this online, guys, and you do, the system does not accept your answers, let me know. I will give you credit for that, but it should. With this, it should. Okay, so how do we find the number of irrelevant responses y when x is 8? So look what you do, guys. Negative 0.963 times 8. I'm replacing x with 8 plus 17.3. And I get 9.596. If you want to round this to whole numbers, because number of responses should be a whole number, I would say 10. So the number of irrelevant responses is about 10 responses right here. So all that explanation, guys, I did is just to come up with that. Now, if we fail to reject the null hypothesis, let me bring this to your attention. And you are asked to answer this question. You would not be able to plug in the x equals 8 in the equation. So what do you do instead? I put a statement here. If we fail to reject the null hypothesis, we cannot use the equation to predict values of y. In this case, if you are given the value of x and you need to compute y, you simply add all the y values and compute, not computer, the average. The average values of all y's is your predicted y value. This is denoted by y with the bar on it. So here's what you do, guys. But we did reject the null hypothesis and concluded that correlation is significant in this one. But if it wasn't the case, you do this, guys, to find the y value. You add all the y's and then find their average. How do you find the average? If you remember from chapter 2, add up the quantities and divide by the number of quantities. So add them up and divide by 9, you get an estimated answer. But no worry about it here, because we were able to reject the null hypothesis, conclude that correlation is significant, so we could use the equation, no problem. Okay, so that's part E, guys. Part F, that's the last part, and that would be almost everything in chapter 9. We're gonna do F. Find the value of R squared, coefficient of determination, and what does it mean? Explain it. You already seen the value of R squared. Let me show it to you one more time. We've done it already. So to find R squared is not a big deal. You go to Stat, Calc, number 4, and L1, L2, calculate, and here is R squared. So R squared is, can you write it down as 4 decimal places? So it is 0.9428. Write it down. All right. So coefficient of determination It is called the ratio of explained variation to the total variation. It's denoted by R squared. You don't have to worry about the formula, just worry about how to find R squared. You already know how to find it. When you find R, you're gonna get R squared automatically. It is 94% in our exercise. Negative 0.97 times negative 0.97 will give you 0.94. And here, for our case, we're not doing diamond now. Y is the number of irrelevant responses, and X is the age of a child. So look, how do you write your conclusion? 94% of the variation in the number of irrelevant responses on a standardized test can be explained by the variation in the age of the child using the regression line. Again, the value of R squared is called the coefficient of determination and represents the amount of variation in Y that can be explained by the variation in X using the regression line. Oh, this is the explanation. We're gonna do another one in a little bit. All right. So this is what R squared is. Any questions about R squared? A shortcut, guys. I'm going to show you a shortcut, and this is being recorded. You find R squared, and if I ask you to interpret the answer, you say, let's say you find R squared to be 80%. You say 80% of the variation in the Y variable, whatever the Y variable is, you write it down, can be explained by the variation of the X variable using the regression line. So you start with the Y and then you go to X because Y is dependent on X. That is a question that fulfills almost everything you need to know in this chapter. To enforce this one, guys, before I show you some other ways to do hypothesis testing of the correlation, I want to do another example, which is example 2. So I'm going to give you a minute to key in the data in L1 and L2. We're going to do example 2 together. Let's do this. All right, so let's do this one. Put the data in L1 and L2 and go from there. Find the value of the correlation coefficient, R. Okay, how do you do it? Let's do it together. You go to Stat, Calc, number 4, press Enter. I got the list, L1, L2, scroll down, Enter, guys, and R is 0.7944. Usually he will tell you how many decimal places when you do this online. So whatever the number of decimal places, 0.7944. So I did 3 here. I put 0.794. Any questions? Part B. At the 1% significance level, test that rho is greater than 0. Okay, testing that rho is greater than 0. You don't need to take any notes. They're all listed there, but I'm gonna just explain to you what we're doing here. So, part B, here's what you write. We wanna test that rho is greater than 0, positive. So here it says correlation is significant. We don't write the claim anymore. And rho, the total opposite correlation, not significant. That's step number 1. All right, and then go to your calculator. I'm going to show you how to do this using critical value approach and a different approach. So I'm going to show you 3 different ways to test the hypothesis. This is the first one. What's the name of the function? Do you still remember, guys? Can someone tell me what was it? Maybe I should do the screen here. Does it ring a bell? Which letter? Here you go, we got some responses here. Yes, linear regression t-test. Don't forget that. For chapter 9, this is the one. It has everything. Okay, so let me scroll up. Enter. Okay, my data is in L1 and L2. Good. Frequency, don't change it. We're testing for positive correlation, so I need to change this one to greater than 0 and calculate. Okay, T is with 3 decimal places 3.204. And the p-value, as you can see, it's 0.0093 to 4 decimal places. Okay, well, the p-value is less than alpha. We reject a null hypothesis. And we conclude there is enough evidence at the, what was alpha in this question? At the 1% level of significance to conclude that correlation is significant. That means you're supporting the alternative hypothesis. Once you say correlation is significant, you are supporting the null hypothesis. Sorry, the alternative hypothesis. X is the number of hours you spend in traffic, and Y is the number of gallons you would consume while waiting in traffic delay. And we want to check if there is a relationship. Well, the logic says there is a relationship. The more you wait in traffic, the more gas you will, your car will consume. So good that we were able to verify that there is a strong linear relationship between the number of hours wasted in traffic delay and the number of gallons wasted while waiting in traffic. Okay, so that was part B. Let's see what part C is. But before I do that, I'm going to show you an alternative way to hypothesis testing. So here we use TI-84, and we use the linear regression t-test. Okay, any questions so far? I'm going to show you 2 other ways to do that. But if he asks you while doing homework that you have to find T and the p-value, you have no choice but doing this. You got to do this method. Here is another way to do it. What is R? What did we get R for? R was 0.794. I'm going to show you 794. Another way to test the correlation. Okay. Do you guys understand what the absolute value of R means? Absolute value of R means if this was negative, you get rid of the negative sign and you write it as a positive. So the absolute value of this R is the absolute value of 0.794, which is 0.794. If this was a negative, the negative sign will go away as a result of doing the absolute value. Let me show you how you could have tested the hypothesis. Watch, table 11. I will provide you with this table if I wanted to do it. It says critical value for the Pearson correlation coefficient. The correlation coefficient that we're talking about is called the Pearson correlation coefficient. Okay, look what it says here. The correlation is significant when the absolute value of R is greater than the value from the table. What is N in our example? Let's count. How many did we have in there? 1, 2, 3, 4, 5, 6, 7, 8. So remember that we have 8. And look how we can use this table. And alpha was 1%. So I'm right here, and 8. The correlation, what did we get here? Eight is 0 when you do n equals 8. And alpha, okay. Let me change, I want to change one number here before I do this work. So this is another way to perform a hypothesis test using table 11. If you come across some exercises in the book where he wants you to use this, the table will be included. There is a link, there will be a link to the table. You just click on it and use it. But make sure, guys, to find the absolute value of R. So if your R was negative, you must make it positive before you use the table. Let's suppose, for example, R was negative 0.855. You make it 0.855 and you compare it with the critical value in the table. And to use the table again, N is how many in the sample. You just count one row, how many in there, and alpha. And as you can see, the table is very limited. It only gives us a 5% and 1%. If the question was about 10%, you wouldn't be able to use this table. That's why, guys, I'm not gonna emphasize much on the use of this table, but it is another tool that you can use. And not this one, it's that one, table 11. All right, let's go to the next question. So we got the p-value less than alpha. We were able to conclude that correlation is significant. And let's see what the next question is going to be. It's going to ask you to find the equation of the regression line. So to find the equation of okay, ready for the next one right here. Predict the number of annual gallons consumed when X is 30 hours. Okay. Well, in order to do that, guys, we need the equation. And you already seen the equation, but probably you didn't write it down. So let's write the equation. You go to Stat Calc. Number 4. Enter. L1, L2, no changes, calculate. There you go. There's my equation. Y hat is 1 point, let's see, 3 digits. X, and my B is 2.814. Okay. He wants the Y value when X is 30. So what do I do in this case? Just like I did in the previous problem. Do you agree that we just replace X with 30? So it will be 1.444 times 30 plus 2.814. Can someone compute this for us? So we get Y hat equals 46.1 hours when X is 30. I want to add one more question, guys, which is not there. What is the coefficient of determination R squared, and interpret its answer? You already know R. And if you want R squared, you guys can get R squared from here again. So run the test, calc. So just get used to this number 4. It's an important one. And let's go. So R squared is 0.6311. Okay, I'll go back here. Or 63.11%. If you want to interpret this one, look what you say. You say 63.11% of the variation in the number of hours spent in traffic delay can be explained by the variation oh, what's X and Y? Let me just double check. Oh, Y is the gallons. So in the number of gallons, sorry, it's the Y variables first, wasted. You waste those gallons. So in the number of gallons wasted in traffic delay can be explained by the variation of the number of hours in traffic delay using the regression line. So my question to you guys, so this tells us 63% of the story, that if you spend more time waiting in traffic, you're going to consume more gas. But there are some other factors that would make your car consume more gas. Can you guys tell me about those factors? It's not 100% that it is because you're waiting in traffic. There are some other factors that are hidden here, not explained. Can you share some with them, with me? What would be some other factors will cause your car to spend more gas? Bigger engine, very good. What else? Type of car. What else? Problems with the engine. Gas leak, type of gas, exactly. So there are some other factors. So that's why, guys, you will never get 100% here. You're gonna get less than 100%, and there will be some other factors that cannot be explained by what we're doing. What we're doing is relating the hours spent in traffic to the amount of gas you consume. But there are some hidden factors which you guys are very good at sharing some of them with me here that cannot be explained with what we're doing. That's what R square will tell us about what's being explained, which is the 63%. But there is another 37% that are not explained by the regression line. Okay. Now, guys, I would like you to go to L1 and L2 and type in the data, temperature, and number of absences. That's your turn. We're going to do this exercise and we will be done. So I'll pause for a minute or so until. So your turn, blank. I didn't put any answers there. You're going to help me, guys, with this. Sketch a scatter plot for the data set and find R and interpret its value. So I wanted to sketch it just for the sake of having a visual there. So how do you sketch it? You just press zoom and then what? What's the magic number, guys? You should know by now. Number 9. Good. Yep. 9. There you go. For first impression, does it look like there is a relationship between the temperature and the number of absences? Very strong positive. I agree. Although we haven't found R. Okay. Yeah, guys, it's obvious. It looks like there is a relationship. You can see it's almost a perfect line there. So let's find R. You go to Stat, Calc, Linear Regression, AX plus B, L1, L2, calculate, and R is 0.98. Wow, it's huge. I'll write it down. Okay, you're right. If you want to see what there appears to be, I agree with the student who says very strong, positive, linear relationship between temperature. I'm not going to put X and Y. For a reader, just put the actual wording. Temperature and number of absences. So it seems when it gets hot, those employees tend to take more days off. They don't want to come back to work. Maybe they want to go to the beach or do something else, but that's what it appears to be. Test for positive correlation between the temperature and the number of absences using alpha equals 0.05. It says use the critical value method, which I'm going to explain to you right now, guys. But let's set up HO. We're going to do it actually both ways, using p-value and the critical value approach. It says test for positive. So will you agree with me if I say rho greater than 0 right here? That's a positive. You read it greater than 0, positive. That's less than 0. I'm going to be consistent. I said in the alternative, you always write correlations is significant. And here you write correlation is not significant. That's step number 1. Step 2. Test statistic, T. This is the formula. If I wanted to use this formula, I will provide it to you guys. But actually, you have access to it as well. But I want to make sure that you can do the algebra to find T. Just to appreciate the calculator more when you see how much work you have to do, and the calculator can do it in no time. Okay, R is 0.98, so you just put 0.98 divided by 1 minus 0.98 squared. And what's n? We said 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 minus 2. Make it 7. Okay. Here is how you use your calculator to find it. You could go to linear regression t-test, but I like to show you how to do the work. So 0.98, look what you do. Divide by second, open the square root, just like I did before. Open parentheses, I'm not gonna forget it now. 1 minus 0.98 squared, close, divide, and 9 minus 2, we already know it's 7. That's how you do it. Watch. To exit the square root, just this key will get you out. And equal 13.029. Okay. The critical value approach. Step 3. draw this curve. You draw that. Probably you missed that. You've been using the p-value for a while. This is the 0 right here. I told you it's a t-test. So that's t. And it's a right tail test, greater than 0. So you shade to the right. And we need to find the critical value. If you remember from chapter 7 and chapter 6, this is called T0. And in order to find it, you need table 5, which I have it ready. And you need alpha, and you need the degrees of freedom. And what is alpha here? Alpha is 0.05. But let me tell you something about the degrees of freedom when you test the correlation. It's not n-1, as you can see in the formula. It says n-2. So instead of looking for 8, which is 9 minus 1, we'll look for 9 minus 2, which is 7. So 7 and 0.05. And here is the book, just to show you the table that you should have a loose copy of it already. I'm sure this table still rings a bell. It's one tail greater, so it's one tail. We say alpha, I forgot what alpha was, 0.05 and 7. Watch. One tail, 0.05 is right here, and 7. Just scroll down to 7. And white. 1.895. There you go. And now, guys, watch. What's the test statistic? 13.029. You agree with me? It should be here because it's huge. It's big. So what's the decision? What decision do we make here? Would someone tell me? The test statistic ended up in the rejection region. So decision would be, waiting for a reply from one student, reject HO. I agree. And then you say, once you reject HO, you can memorize this conclusion. There is enough evidence at the 5% level of significance to conclude that correlation is significant. Between the temperature and the number of absences. I didn't have room to write this down, but that's the conclusion. Now, guys, if you wanted to use the calculator, if I give you the choice to use either one, look, we could have done this. Stat, tests, scroll up. It's linear regression t-test. It's the letter F on most calculator. Not sure if it is on all calculator, but it is a letter F. L1, L2, frequency, don't change it, greater than 0, and we should not get any conflicting, contradicting results. Watch. T is 13.031. What did we get? Oh, see, it's very close this time. 13.029, which is 0.3, and this rounds to 0.3. So whether you get it off the calculator by hand, the system will recognize this. P-value, would someone tell me what the p-value is with 4 digits? Look at it. What is the p-value here? Yes, it will be, don't be afraid. Yeah, 0, I agree. It's 0, less than alpha. P-value is less than alpha, you reject the null hypothesis, conclude correlation is significant. You see the degrees of freedom, guys, it says 7 here, which is 9 minus 2. And not only it gave us, you know, the p-value and the test statistic gave us the equation of the line. If you want to copy the equation of the line off the screen, that is fine. But remember, look how it's written here. You cannot write it ax plus b. He does it at a plus bx. Okay, what is a here? Negative 30.27. So I'll write it from here. Plus bx. B is 0.449. Okay, and then x. Whether you use the other formula or this one, you should get the same equation. And the next question, what would be the number of absences in a given day if the temperature is 95? So here we replace x with 95. So y hat would be negative 30.27 plus 0.449 times 95. And let's do the math on the calculator. Right, so quit. Negative. When you use a negative sign, guys, you make sure you start with this, not that. You'll get an error if you do that. So negative 30.27 plus 0.449 times 95. I got 12.385. So about, cannot have half of an absence, so it's about 12 absences. And number 5, find the coefficient of determination R squared. You already have it. Here you go, stat, calc, or you can square R if you want. But if you don't want to do any work, watch. So R squared is 0.96.04. I'm just gonna do 3 digits, so 0.960. Change it to a percent, which is 96%. Okay, I'm gonna write the conclusion. I didn't have room, but I will try to squeeze it in here. What do you say? You say 96% of the variation in number of absences. You see, I start with Y first. Can be explained by the variation in temperature. Using the regression model. There is a 4%, guys, that is not explained by the regression model. What do you think would cause employees to be absent other than the temperature? Can you think some other reasons that would make employees not come to work? Can you give me one example that covers that 4%? Yes, sickness, I agree. Didn't wake up on time. These are the 4%, exactly. I mean, it could be sickness, it could be some other things. Okay. All right. One more thing, and we will be done, guys. And I will let you. I will let you go after this. I'm just gonna explain these last 2 statements, and we will be done. Do you guys agree with me that there is a relationship between smoking cigarettes and lung cancer? Okay, good. But do you think it is safe to say that smoking tobacco causes lung cancer? Yes or no? Okay, some of you are saying yes, some of you, actually the answer is no. Not everyone who smokes cigarettes get lung cancer. So you guys, you have to understand, if there is a relationship between two entities, it doesn't mean that one causes the other. So that's what this title is called, correlation and causation. I wanted to understand, if there is a linear relationship between X and Y, it doesn't mean that X causes Y or Y causes X. It could be the case, but not necessarily as Fatima said. Exactly, it could be the case, but probably not. So I want you to understand that.